We are now in 8-3, multiplying polynomials. Now in your book, this is in your book on page 480. Actually, this graphic is on page 481. In your book, they recommend a few different ways of multiplying polynomials, but I'm going to cut right to the chase. This is the method that everybody uses, this method called the FOIL method. Now we multiply two polynomials. What we're talking about is something like x plus 4 times x minus 2, the quantity x plus 4 times the quantity x minus 2. And when we use the FOIL method, FOIL is a mnemonic. It says to multiply two binomials. FOIL method, that's important. The FOIL method only works with binomials. It does not work with trinomials. It does not work with a monomial and a binomial. It only works with two binomials. But when multiplying two binomials, find the sum of the products of the first terms, the outer terms, the inner terms, and the last terms. That's first, outer, inner, last. That's where we get FOIL, F-O-I-L. So this is what it looks like. We've got our binomials x plus 4 and x minus 2. The product of our first terms, this is our f, that's this x times this x, and we've got them right here. Our outer terms, well our terms on the outside are this x and this negative 2. So we've got x times minus 2. The product of our inner terms, these are our inner terms, you see the green I, we've got the 4 and this x, so the 4 times the x. And then our last terms, we've got a 4 and a negative 2, our last terms, the last one in this binomial is a 4, the last one in this binomial is minus 2. So then we're just going to add all of these up. Well, our first term is x times x, which is x squared, that's right here, plus x times negative 2, which is negative 2x, which we put right here, plus 4 times x, which is 4x, which we put right here, plus 4 times negative 2, which is negative 8, which we put right here. So this is simplifying, and now we have to collect our like terms. Whenever you do this with a binomial, you're going to have an x squared term, and you're going to have a constant, and you're going to have two x terms, two terms with x. So you're going to have to collect the x terms. So our x squared goes down here, our negative 8 goes down here, and then we've got negative 2x plus 4x. So we end up with positive 2x. This is called the FOIL method. Let's do a couple more examples. All right, this is your next problem. This is example 2 on page 481 in your book. And we are multiplying the quantity 2y minus 7 times the quantity 3y plus 5. Notice we have one y term in each of the polynomials, and we have a constant term in each of the polynomials. So using the FOIL method, our first, and here I've got the little arrows here for you again, our first term in both, we've got the 2y and the 3y. So notice the f, our 2y, and our 3y. So I'm going to mark them down here, 2y times 3y. And then our outer is 2y times 5. 2y times 5. So I'm going to put a plus 2y times 5. And then our inner is negative 7 times 3y, right here. Negative 7 times 3y are our inner, that's the green. So I put plus negative 7 times 3y plus, and our last terms, we've got this negative 7 and this plus 5. See our last terms, negative 7 and this plus 5. So I'm going to write negative 7 and 5. Okay, equals. So at first, I've got my 2y times 3y, which is 6y squared. So I'm going to write that down, 6y squared. And then I've got plus, and I've got my 2y times 5, which is 10y, plus, then I've got my negative 7 times 3y, which is negative 21y, plus, and then I've got my negative 7 times 5, which is negative 35, equals. Okay, so I bring down my 6y squared, because I'm collecting like terms now. Then I've got 10y minus 21y, so it's negative 11y. And then I've got plus a negative 35, so it's minus, that's not right. That's supposed to be a 5. Go away, go away. It won't go away. All right, I'll just cross it out. Minus 35. Okay, so I've got 6y squared minus 11y minus 35. Here's another example of multiplying binomials, 4a minus 5 times 2a minus 9, and this is example 2b in your book. They go through it a little bit different method. I'm going to show you a method that uses a little bit less writing, because I realize that sometimes when you write a bunch of stuff, it's made to show you the way that everything's going on so that you can see what's happening, but sometimes it looks like just a lot of work when it's really not that much work. So I'm using the FOIL method. So I'm going to take my first terms, which are 4a times 2a. Well, 4a times 2a is 8a squared. Plus, my outer terms are 4a times minus 9. Well, I know 4a times minus 9 is negative 36a. Plus, my inner terms, negative 5 times negative 5 times 2a, which is negative 10a. And then my last terms, my negative 5 times my negative 9 is 45. Okay, and now all I have to do is collect my like terms right here with the a's. So I just copy down 8a squared, and then I've got negative 36a minus 10a, so that's negative 46a plus 45. And that is my answer. Now here's one that's a little bit hairier. The problem with the FOIL method is it only works for binomial times a binomial. Here we have a binomial times a trinomial. So the FOIL method's not going to work for us, so we have to use a little bit different method. I'm going to break this down using the distributive property. You see that I've got my first binomial in red and my trinomial in blue. I'm going to break this down a little bit different way so that it accesses some knowledge that you already have with multiplying a monomial by a polynomial. So anytime we multiply two polynomials, we have to multiply each term in one by each term in the other. That's why they get to be such big messes. So we're going to have 6 different terms in this one. When we have binomial times a binomial, 2 times 2 is 4, so we have 4 terms. With a binomial times a trinomial, 2 times 3 is 6, so we have 6 different terms that we're going to have to combine. So this is the way that I'm going to do it. I'm going to use the distributive property and do 6x times 2x squared minus 3x minus 5, and then I bring down my plus 5 times 2x squared minus 3x minus 5. So now this uses the distributive property, so I'm multiplying the 6x times everything in my trinomial, and I'm multiplying the 5 times everything in my trinomial. So I am going to be multiplying each term in one by each term in the other. So now you know how to do this. This is simply multiplying a monomial by a polynomial. So I will go through this. 6x, my 6x times my 2x squared is going to give me 12x cubed. Then my 6x times my negative 3x is going to give me negative 18x squared. My 6x times my negative 5 is going to give me negative 30x plus, and then I'm coming over to my 5. My 5 times my 2x squared is going to give me 10x squared plus my 5 times my negative 3x is going to give me negative 15x plus my 5 times my negative 5 is going to give me negative 25. And now I can collect my like terms. I only have one x cubed term, so I just bring it down. 12x cubed plus I have negative 18x squared, and I have 10x squared, so that's a negative 8x squared, plus, for my x terms, and see I'm doing this in standard form now, from highest to lowest degree. My x terms, I have negative 30x plus a negative 15x, so it's a negative 45x plus, and then my constant, I have a negative 25 at the end. So plus a negative 25. And now I'm just going to change them all to get rid of the double signs. So I've got 12x cubed minus 8x squared minus 45x minus 25. Yeah, I know that's kind of long, but you see how using the distributive property, when you have a binomial times a trinomial, you can break it down into things that you already know.